Number 1. So I give you a picture of a function and you've got to give me what the function is. So this should be a dotted line, and it starts off, the V means it's going to be some type of absolute value, and if you have absolute value it starts at 0, 0, and this one has been shifted to the right twice and then up twice, so it moved over 2 and up 2. So moving it over 2 to the right, that happens inside the parentheses. If you add or subtract inside the parentheses, that moves the vertex left and right. So we moved it right twice, so it should be minus 2. And then outside the parentheses, this vertical shift of up 2 is plus 2. And then everything is shaded underneath it below, so that's less than. And it's a dotted, so it just stays less than. If it was solid, it would be less than or equal to. Number 2, we need to substitute this in place of this. So your function is this: 4 multiplied by whatever n is, subtract 3. And in place of n, we're going to substitute these two things. We're going to substitute n minus 1. So now you need to multiply whatever you plugged in by 4. So let's time both of them by 4. Times the 4 to the n, that's 4n, times the 4 to the minus 1, that's a minus 4. And then you just got a minus 3. So these two combine, they're like terms. So you got f of n is equal to 4n minus 7. 3 is a little bit easier because you're just substituting in one number, one value. 2, you had to substitute some algebra, a letter and a number. So 3, it's 2 times whatever you plug in squared plus 2. And I'm going to substitute in place of x, I'm going to substitute a negative 3. So I'm going to put a negative 3 in there. So whatever you plug in, you got to square it. So first move is you got to square it. That is a negative 3 times itself, a negative 3. That is a positive 9. So now we got this: 2 times 9 plus 2. 2 times 9 is 18. 18 plus 2 is 20. So your answer is h of a negative 3 equals 20. This is what I'm looking for. 4, okay, you're given a table and you gotta graph the data. So weeks, this is gonna be your x, 1, 2, 3, 4, 5, 6, 7, and then your pairs sold. This is gonna be the y-axis, this is x, this is y. So all the way to 44. So if I count by 5s, that's going to be 10, 20, 30, 40. Okay, at week 1, there's got to be 8 pairs, so that's somewhere there. Week 2 is 10 pairs. Week 3, go to 15. Week 4, go to 22. Week 5, go to 31. Week 6, go to 44. Okay, that's it. Do not connect these dots with a line. I gave you points if you did, but on the retake I'm not going to, because, well, never mind, I might. I think I can't remember, someone said there is stuff going on between week 3 and week 4. You're selling shoes between week 3 and week 4. So there could exist values at week 3.5, week 3.5, or week 3, day 2. So there could be stuff existing, but we just want a discrete graph. We just want these 6 dots, so don't connect them with the line. Okay, the domain and the range. The domain is the x, so the domain, there's more than one. 1, 2, 3, 4, 5, 6. The range are the y's, so the range is 8, 10, 15, 22, 31, and 44. Gotta use those brackets. So there's nothing in between 8 and 10, 10 and 15, 15 and 22. We're just these 6 values, that's it. Is this a function? Yes, because the vertical line test. There's not more than one dot on every vertical line, so that is a function. Okay, 5, we got to graph it. So we've got y equals 4 minus x. Okay, the m is a minus 1, and the b is 4. So the slope is minus 1. Let's put it over 1. This is your y-intercept. This is your first dot. So up at 4. 1, 2, 3, 4. You got a dot. Then go down 1, right 1. Down 1, right 1. Down 1, right 1. Down 1, right 1. Okay. Now this only exists. So I got a line going through all these dots. But it only exists when x is greater than 0. So on the x-axis, here's 0 right here. Anything bigger than 0 is to the right. So my boundary line is right here, right at 0. And this line exists only on the right side of 0. So I've got to erase all of this, and it does not even exist at 0. So at 0, it's got to be empty. That's where it starts, and then it takes off forever. Okay, the next one, we got y equals a negative 2x minus 2. So my m is a negative 2, my b is a negative 2. So the b, that's your first dot. Come down here at negative 2, 1, 2, you got a dot. And then your m is negative 2. So go down 2, right 1, and I'm out of space. I'm going to go up 2, left 1, up 2, left 1, up 2, left 1. Okay, all these dots. But this only exists on the other side of 0 when x is anything less than 0. So here's 0. So this dot does not exist on 0. So it's got to be empty. And it exists anything left of 0, anything less than 0. So your picture's got to look just like that. Okay, the domain is anywhere left and right. So this goes all the way to the left. This red line goes all the way to the right. So it covers all the way to negative infinity, to positive infinity, but it does not exist right here. Never at 0 can you find anywhere that touches the line. So the range is going to go from the domain negative infinity to 0, not including, so parentheses, and then 0 to infinity. Okay, the range up and down, this blue line is going to go all the way up, and this red line is going to go all the way down. Positive infinity to negative infinity, and everything in between, because these two overlap a little bit. So this one's all the way up, this one's all the way down. Negative infinity all the way to positive infinity. Number 6, a stitching time charges $40 an hour or any fraction thereof for labor. Draw a graph of the function that represents this situation. $40 per hour. So 0 to 1 hours or any part of that, she is charging you $40. So $40 the whole time. And on 1, she's charging you $40. 0, she's not charging you anything. As soon as the clock starts, that's when the line exists. That's when the charge occurs. 1 to 2 hours, it's going to be another $40. So we're going to jump up here at 80. At 1 hour, it's empty because she's charging you 40. But then as soon as the clock leaves 1 hour, you got to pay 80. So if she takes her 1 hour and 1 minute to stitch your stuff, you got to pay $80. Anything past 1 hour. Okay, 2 to 3 hours, it's going to jump up another $40. And it's going to be so on and so forth. So this is a step function. Okay. The domain is the x-axis, how far left, how far to the right. So the domain is either 0 to 7, including 7, not including 0, or you could even probably argue, well, she could go to infinity. She could stitch her heart out forever. The range is discrete. So the range is only a certain set of numbers. The first element is 40. You're never going to have to pay 20 or 10 or 30. 40, then 80, then 120, then 160, etc., etc. So all the elements in your range are just these multiples of 40. Okay, now 7. Okay, we give you the picture of the piecewise function. You have got to come up with the function, so let's do this guy right here. That is my b. My b is 0. The m, from this dot, go from dot to dot. Looks like there's a dot there. Looks like there's a dot there. So I'm going up 2. No, I'm going up 3. 1, 2, 3, over 1. Down 3. Okay, so up 3, right 1. So 3 over 1. So my equation is this. Y equals 3x plus 0. And that exists if, here's the starting point right here. It's existing right there. Okay, your boundary line. On the x, that happens at -1, -2. So if x is what? -2. Bigger than, smaller than, anything greater than -2, anything to the right. That is when that line exists. Okay, this other one. Let's find some dots. There we go, there we go. So it looks like up 1 over 1, up 1 over 1, up 1 over 1. So there's my b. My b is 2. M is up 1 over 1. So m is just 1. So it's y equals x plus 2, or 1x plus 2. If x, okay, it has the same starting point. It starts at -2. But it's going left, everywhere left of -2, so it's going to be less than, and because it's shaded and filled in, it's going to be less than or equal to. Number 8. Write a function that transforms this. Okay, so a lot of you guys drew pictures and that was good. I liked that. So x minus 3, this is squared, so it's not an absolute value, this is a quadratic. X minus 3, that means we're going to go 3 to the right, 1, 2, 3, and then up 2, 1, 2. So there we go, and it's quadratic, so it's going to be a parabola. Now, you need to take this, slide it up 1 unit. So take this vertex up 1, and then 2 more units to the right. So if you're going to go up 1, you're going to add 1 to this 2. It's going to end up at 3. 2 units to the right, that's going to be over here. So it's going to be up 1 unit, okay, something like that. So we're going 1, 2, 3, 4, 5. We're going to go over 5 units and up 1. So there we go. So 2 more units to the right, instead of going to 3, we're going to go to 5, and then 1 more unit up, instead of going to 2, we're going to go 3. The next one, flip it over the x-axis. Okay, that happens if you put a negative, and then slide it left twice. Okay, this one's tricky. So x minus 3, that's 1, 2, 3 to the right. If we're going to go left twice, we're going to end up right here. So I just want it, first I want to flip it, so it's got to be negative. X, I'm only going to go over 1, x minus 1 squared. Okay, number 10. An artist can sell each drawing for $100 and then each painting for $400. He hopes to make at least $2 grand every month. So A, not very many of you got this. Write an inequality. Let's put this English into an equation. So here we go. $100 for all my drawings. So if I do 4 drawings, I just do 100 times 4. So how many ever drawings you do times by $100. You take that income, you add it to the income from his paintings. That's $400 he's getting for every painting. And if you add those two, it's going to equal $2,000. It's going to equal at least $2,000. That would be awesome if he made $10,000 in 1 month. So the very minimum he wants to make is $2,000. So his earnings need to be bigger than or equal to $2,000. So here's your inequality. $100 a drawing plus $400 a painting. It's got to be greater than or equal to $2,000. So let's graph it. If we're going to graph it, here's the drawings on the X and the paintings on the right. What if I don't sell a single drawing? How many paintings is he going to have to sell to hit $2,000? He is going to have to sell 5 paintings, because 5 times 400 is $2,000. Or the other way around, what if he does not sell any paintings? What if he does it all in drawings? How many hundreds are in $2,000? And that is 20. So you got a dot at 0, 5, and you got a dot at 20, 0. Okay, you're going to connect these with the solid line, because here is your line right there. This dot, anywhere on this line is going to be exactly $2,000. But he hopes to make more than $2,000, so you shade everything above it. Okay, if he sells 3 paintings in 1 month, so 3 paintings, let's put 3. 400 times 3, that's $1,200 he made. How many drawings is he going to have to sell? So 1,200, he wants to make $2,000. So I subtract that, that's 800, $100 a drawing, he's got to make 8. Okay, last one, the bonus. So here's a formula, it's just like this. Girls equal 2 times the boys plus 3. Or even y equals 2x plus 3. Okay, is 10 ever going to show up in the range? The range is the y's. That's the girls. So can you ever have 10 girls? The only way you're going to have 10 girls is if you have divide by 2, divide by 2. 3.5 boys will give you 10 girls. So the answer is no. You cannot have 10 girls because it's impossible to have a fraction of a boy. So that's B. Can't have 3.5 boys. What about C? Can 10 ever show up in the domain? The domain is the X. The domain is boys. And the answer is yes. If he has 10 boys, then first thing you do is times it by 2. That's 20. Then plus 3. 10 boys equals 23 girls. And those are both whole numbers. That's totally possible. That could work. And I think that's it for the test. Make sure you know your stuff.